I am going to make today's video as short as possible, so I don't take up all of your time. So, all week, we've been seeing how astronomers have spotted distant galaxies so unusual it's starting to challenge the very foundation of how we believe the universe began. Right now, instead of supporting the familiar Big Bang idea, these discoveries are pushing scientists towards something far more mysterious. What if our universe evolved in ways we've never imagined? One of the key voices behind this idea is Roger Penrose, a Nobel Prize-winning physicist. He suggests that the universe doesn't just begin and end once. Instead, it moves in endless cycles of death and rebirth. And even more fascinating, he believes there could be traces of a previous universe still visible in our sky today. Now, the standard view of the universe looks something like this: a Big Bang at the beginning, followed by expansion, stretching out into the distant future. But Penrose suggests something different, that this stretched out infinity eventually becomes the next Big Bang. He calls each cycle an eon, meaning there was a universe before ours, and there will be another after. So instead of a one-time beginning, the universe may actually be part of an endless loop. Now, it might sound outrageous, but Penrose argues there is real evidence behind it, not absolute proof, but enough to take seriously. And then, something even more surprising happened. When the James Webb Space Telescope looked deep into space near the Big Dipper, it detected faint light that had been traveling for over 13 billion years. These were galaxies formed just a few 100 million years after the Big Bang. But here's the problem: they were already massive, as large as the Milky Way. That shouldn't be possible. According to our current models, there simply wasn't enough matter that early to form such huge galaxies. And yet, there they are. So strange, scientists have even nicknamed them universe breakers. Then Webb found even more galaxies like this, each one packed with far more stars than expected. And this didn't just challenge galaxy formation. It also created a serious problem with something called the expansion rate of the universe. For years, scientists have used the Hubble constant to measure how fast the universe is expanding. Theoretical models predict one value, but real observations keep giving a higher number. And now, Webb's data is making that gap even bigger. So the question is, why doesn't reality match our predictions? Some scientists are now asking something bold. What if our universe isn't alone? What if it's interacting with other universes? Maybe what we see as expansion is actually something much bigger, a merging or stretching of multiple cosmic regions. In other words, our universe might just be a small part of a much larger multiverse, and Webb might be giving us the first clues. As researchers explored this idea further, they found something incredible. Their new models actually match real observations better than the old ones, which means this isn't just a small correction, it's shaking the foundations of modern cosmology. More and more scientists are realizing something important. We don't fully understand the universe, yet every new discovery reminds us science is always evolving. Now, to understand why this is such a big deal, we need to go back to a time before stars even existed. Back then, the universe was filled with thick hydrogen gas, a kind of cosmic fog. Light couldn't travel freely. But when the first stars formed, they began clearing that fog. This moment is known as cosmic reionization, and according to theory, it should have started around 300 million years after the Big Bang. At first, only small pockets of light existed. The rest of the universe remained dark, or at least, that's what we thought. Because then, Webb discovered something shocking. A galaxy called Jade's GSZ 11, shining brightly just 330 million years after the Big Bang. And not just shining, it was releasing huge amounts of ultraviolet radiation, far more than expected. Scientists even detected something called Lyman alpha radiation, which shouldn't have been visible that early. So now the question becomes, did the universe light up earlier than we thought, or did it happen much faster? Because if this is true, then our entire timeline might be wrong. This galaxy had already created a massive bubble, allowing light to escape, something that should have taken much longer. So what does all this mean? Either our models are incomplete, or something deeper is happening. Maybe Penrose was right. Maybe the universe doesn't begin once. Maybe it cycles again and again. What if the Big Bang wasn't the beginning at all? What if it was just a transition from a previous universe? Penrose calls this idea a cosmic cycle, a universe that keeps dying and being reborn again and again. And here's the most fascinating part. He believes we might already have evidence, hidden in something called the cosmic microwave background, faint radiation left over from the early universe. Inside it, he found unusual circular patterns, which he calls Hawking points, possible traces of black holes from a universe before ours. Of course, not everyone agrees. Many scientists remain skeptical. But then again, black holes were once considered impossible too, and now we know they're real. So maybe, just maybe, we're already looking at the evidence, and we just don't fully understand it yet. So, to everyone watching, thank you. Your curiosity, your support, is what makes all of this possible. Every view, every comment, keeps this journey alive. And to my members, you're not just supporting a channel, you're helping build a community that's exploring the mysteries of the universe. I truly appreciate every single one of you. Thank you for being amazing.